because of poor work practices, right? When you perform good work practices and housekeeping, right, then you will eliminate a lot of the hazard. Sometimes you can substitute the hazard, meaning if the machine don't have a guard, right, you change out the machine to a machine that have a guard, right? This is how we substitute a hazard, right? Make the hazard less and in terms of grading. Good. As well as sometimes you can change a particular machine and it does eliminate that hazard, but it presents another hazard, right? Which is less than the one before, right? So it might not be as life-threatening than the previous piece of equipment. Now, elimination of the hazard, right? We just say something about that, but in terms of electrical now, we're talking about like your interlocking circuitry, right? You can have a physical interlock circuitry, which is mechanical, and you can have an electrical interlock. Well, the most secure form of interlock circuits is a mechanical interlock, right? A lot of machines will have mechanical interlocks to prevent you from energizing the machine accidentally, right? And these are basically, when you're talking about electrical interlock, right here we're talking about low voltage values such as 24 DC, right? Using that instead of 120 volts, right? Even though we can get shock from DC, but we're talking about high voltage DC in these cases, right? So a 24 volt DC interlock circuitry will not pose as much danger to you as the operator, right? So that is one example of, and if you have not seen a mechanical interlock physically, guys, you can visit the power lab, and those gray machines that you see over the other side that we have not run, right? They actually run, they actually work. A lot of them over there have mechanical interlock. So before we have all of these red machines that I used before. So like my persons who doing drives, electric drives and machines this semester, right? You'll be using your dissectable machines, the red machines. Now, before these red machines, we had to use the gray machines. And these machines are designed with a lot of mechanical and electrical interlock. So as persons cannot accidentally operate because of the size of the motors, right? And again, when we're talking about operating these motors, we have to remove jewelry, we have to remove ties and so forth because they can be caught in the rotating shaft, right? So that is one way of eliminating a hazard. But in this case, and in today's society, guys, a lot of these equipment, because a lot of these portable devices, like drills and so forth, for instance, most portable drill, you can actually lock it, so you cannot press the trigger, right? The lock mechanism for most of them is actually putting the switch that switches between forward and reverse in the center. Once you put it in the center, you are unable to squeeze the trigger, right? A lot of these devices are like that. They are designed with these locks to prevent you. So it's a mechanical interlock rather than a electrical interlock. When you put it in the center, the trigger is unable to go into the slot to press, right? So it's a mechanical protection against hazard. And a lot of portable tools are employing this type of operations. For instance, your angle grinder, the same angle grinder I'm talking about, for you to switch it on, right? Most of them you have to push the like a switching off and on a toggle switch, you have to push the button and then you slide. So you can't just push the button because there's a physical mechanical interlock that prevents you from just going there and push the button, right? You have to rock it and then slide it along before you can start the angle grinder, right? And for persons who don't know how to use angle grinder, you don't keep your hand on the start switch, right? You actually start it. So I mean, don't keep your hand on it to keep it on. You should fully turn it on and latch it and then hold the angle grinder properly and do what you're doing, right? With the slightest touch of the switch, it is so designed that the slightest brush of the switch will trip it and return it to the off position. Yes?
Yeah, I'm saying that these safety measures really to prevent the equipment or the appliance, the machine from being operating at a time when you don't want them to
Yes.
operate accidentally. Even the same thing with a gun. We have the safety lock on it. Even the same thing with a gun. There's a safety lock on it to prevent the gun from being fired when it was not meant to be fired at the time.
Yes.
So just the safety features.
Yes. And we are saying that these are types of engineering controls, right? It was engineered that way to prevent accidental operation, as they say, or unwanted operation. All right? And we are saying that a lot of time these is things will happen over. You realize and these manufacturers sit down and are pressured in today's society to design ways of disabling the devices, right, when not in use. All right, engineering control. I think with exhaust engineering control, anybody who don't know engineering control by now, right? So if you see this on a test, you should be able to explain what an engineering control is and give an example of engineering control, all right? Now, administrative control also, we're talking about physically tagging out a device and so forth, documentation and so forth. We have exhausted this also, right? So that's one of the hierarchy. And again, personal protective equipment, you have been hearing about this from probably year one when you go to your lab rooms where you are asked to wear your lab coat and your safety goggles and wear no open toe shoes, no slippers and so forth in the lab. These are all PPE type controls that are put in place to protect you. All right. So PPE is more personal type protection compared to the other two, right? So even though the other two are there, guys, I'm telling you that PPE is normally 100% of the time, or even probably, I should not say 100, but probably 95% of the time you have to wear PPE with the other types of controls. All right. We looked at this last week, but this is one way. Last week we looked at it in a different context, and we said fuses and overcurrent devices are really put in place as a form of control measures to protect us, right? And protect the equipment. All right. The GFCI again, a better picture this week, and we are going to be looking at the device itself. We are saying that these devices basically are designed to limit line to ground shock current to less than 5 milliamp. So we are saying that between 4 and 6 milliamp, right, the device will trip in less than 20 milliseconds, right? Very fast, right? So before the current level can become dangerous enough. Remember when we look at the levels of electric shock, this device is so designed to keep you in the threshold of perception area, right? So before it can become hazardous and harmful and cause electrocution, the device should operate, all right? So we're talking about, so this is a picture now, a circuit diagram of, internal diagram of a simple GFCI, ground fault circuit breaker, interrupter, right? Circuit, right? Now, the principle of operation, guys, is that if you look right here, where you are seeing this, the line, which is a phase, it's wrapped onto the core, right? You realize it's one core, and this line is wrapped around the core and feed to one side of the load, right? And then the load, from the load now, your return or your neutral will wrap around the same core and feed back to the supply. Now, everybody by now should understand the principles of induction, right? We are saying that if you have this coil in a particular direction, remember we said these are directional, right? Or you wind the coil will be directional. No, the current flowing through this coil will set up a magnetic field in a certain direction, right? And if this is of the opposite direction, that's the one in the neutral now, because they are equal. So remember, you know, if you have a good working device, current in must be current out. Remember when we do Ohm's law, we do the simple resistor in our circuit and we could take the current at any point, right? So we are saying if we were to take the current here in the line and we were to take the current in the neutral, we should be getting the same current, correct? Correct, right? So if that is the case and the magnitude is the same and the direction is opposite, by rules of vector, we are saying that the induced voltage would be what? Anybody? The induced voltage should be
at the end of the wire, at the end of the coils.
It should be 0.
Yeah? What should be the induced voltage? 0. Thank you, Mr. Robinson. The induced voltage would be 0. Remember, you know, we said the magnitude is the same, but the direction is opposite. And if we have, by rules of vector, if we have two vectors that are equal magnitude in opposite direction, your resultant will be
cancel out each other.
Yes. Yeah? Repeat.
I'm saying they cancel out each other, so the voltage will be.
It would be 0, so we don't have a voltage induced, don't it? No. We are saying no. When you wire this device, right, for persons who are aware of the device comes with a earthing terminal, right? The breaker comes with an earthing wire that you carry that wire directly to the earth bar in the panel, right? No. And this is why the earth is critical. No, the device operates on earth fault only, right? So when you have a short circuit between line and earth taking place, you are going to have what? A leakage current, don't it? So now you have a node develop, right? All of you do circuit analysis. If we have a leakage current, at that point we have a node, right? Meaning some current going to flow to earth, the majority of the current, and some current is going to flow back to the neutral, correct? We'll get the engineering right, you know, we learn the theory, we'll see how the theory apply. Now, if this is the case now where you have a node develop and you have a short circuit current to earth, then the current entering this core and from the line and the current entering from the neutral, which is the return current, will be of different magnitude, correct? And if they are of different magnitude, we are going to have what? A voltage difference, no sir? So we are going to have a resultant developing, and this resultant will cause a induced voltage now in the trip coil. You see the trip coil and the trip winding. So we have the trip winding, we're going to have an induced voltage, and because the coil is this, the trip winding goes to a coil that is continuous, so we have a closed path for current to flow. A current will flow, and if we have a coil around a shaft, that's basically a solenoid, and the breaker and the switches or breakers in the device will operate, right? Simple operation, you know. Two coils, let me say it again, I'm saying it again, two coils, one going in one direction, the current flowing, the other in the other direction. When the magnitudes are the same, the resultant is 0. There is no induced voltage. Now, if we have a short circuit to ground, then the current flowing into the device and the current flowing out of the device to the return, that's a neutral, will be opposite, but they will be of different magnitude. Hence, there will be a resultant, and that resultant will produce an induced voltage in the trip winding, right? So here we have the trip winding, you'll have a voltage develop. Because it's creates a closed path, right, you will have a current flowing. And this current, because of how it's designed with this solenoid, right, it will operate the switch and it will cause the device to trip. Simple. Now, the test button, remember, looking back at the device, you see I have a test button. So we have the reset button and we have the test button. Now, how the test button works is that you realize that you have a resistance here. So this is put in place as not to directly short this neutral to the live, right? Which will create a short circuit imbalance in the current. Now, if you if you were to close this test button now, because we develop a node here, so again, then you're going to have some current flowing here and some current flowing here, and then the current in this coil will be different from the current in this coil, and you will also have an induced voltage in the trip winding, and hence a current will flow in the trip coil and cause the device to operate. And what is that?
Come on, because as long as the return current is larger than the input current, because the return current is what goes through the neutral.
Yes. All right. So,
once you have a short circuit, the current is going to be larger, which creates the larger voltage. So you're not going to have a
it's not going to be balanced. It's going to have a resultant. Yeah.
Have a resultant, right? And therefore, it will cause the trip coil to operate.
All right. So it's a simple circuit, guys, but very effective. And you realize because of how the circuit is designed, the small change in these two current values, that's a line current and a neutral current, right? The device will trip. So before it becomes dangerous to the point that you are exposed to probably a touch potential, right? The device will trip and trip out the circuit, right? Now, based on regulation, right, we are saying that even though we can have a maximum of 4 plugs on a circuit, right, our local regulation only dictates us to put one plug on the load side of a GFCI, right? So, unlike the regular circuit, only one plug this device can control. So if you have a GFCI plug, right, a socket outlet, you only can connect one other socket outlet in parallel to the output. Because when you look at this plug, you would have one side marked input and one side marked load. The side that is marked load will actually be where you put your extra plug on. So any plug that will feed, if this device was to trip, that plug will also trip, right? So once the device trip, or if there's a short circuit in that plug as well, it will trip the device. All right, so that's the operation. It's on this slide. You can go through it in a detail, right, when you are doing your reading, but I like to go through as I'm pointing on the circuit so you can have an idea of what is taking place, right? So this is really your operation of the circuit, right, and how it operates to give you the trip condition, right? So remember, guys, the circuit will work on ground faults, right? If you have an overload, meaning in a case of an overload where this device is pulling more than what the breaker can supply, right? And not too much, for instance, right? Say it is probably the breaker can supply 15 amp hour, probably at 15.5 or 16 amps. Then this device will not trip. It's the breaker that will trip, because this device does not look for overload or overcurrent. What it looks for is short circuit current. All right. All right. So we're on lockout. So we're still on types of control. we talk about this in brief the other day. So now we look at it in much more detail. We talk about, and this is the abbreviation lockout, tag out, right? So you are LOTA, right? You need to perform LOTA, right? So once you hear a person mention LOTA in terms of electrical, right, it is telling you about lockout and tag out, right? And we say this is basically the formal process for controlling hazardous energy, right? LOTA protects personnel working on equipment from the unexpected release of hazardous energy. It is composed of two principal process components. De-energization, that's removing all energy sources from the system. Control prevents re-energization. That's where the lockout come in, right? So the lockout prevent re-energization, while the first part of the process is where you go and de-energize the circuit, then you will lock out, and then you will tag the system. All right, when is LOTA required? I would say LOTA is generally required for all servicing. I need to tell you this because you can't service a machine when the machine running, right? Most of the time, you have to perform mechanical servicing on the machine as well as electrical servicing. And if it's a rotating machine, even if it's not a rotating machine, right, you need to lock out and do your tag out processes, put your tag that machine is being repaired and maintained, right, before, so that nobody can go and energize it. Now, this very serious situation, right? More specifically, certain programs define hazardous energy threshold that trigger the application of LOTA. For example, guys, electrical line voltage above 50 volts AC is considered hazardous and requires LOTA. So what they are saying that any voltage level, once you're working on a machine that is over 50 volts AC, they need to apply LOTA. Right, this is an OSHA requirement. This is our IEE requirement. This is our JS21 Jamaica standard requirement that all devices over 50 volts AC, once being maintained or repaired, need to have a lockout and tag out process. Right. However, a lot of time we don't lock out, but we de-energize, right, and we carry out work and then we energize, right? But a good practice is always to lock out the device, right? And they say that whenever the person is closer than 42 inches or exposed electrical circuit parts, of electrical exposed parts, right? So that's basically live parts. Now, who is required to perform LOTA? Because we can't just left out LOTA, so. Each and every person who is performing work on the equipment or who is entering an area with hazard controlled by LOTA is required to apply their personal locks and tags. It means if a 5 of you work on the equipment, the 5 of you might not be working on it at the same time. You might have the electrical team, you might have the mechanical team. Right, each person should have their own locking device to lock the machine out of service. Meaning, if the mechanical guys want to energize, they need to call the electrical guys, right? If the electrical guys want to energize to test something, they need to contact the mechanical guys because they might come and work in the evening and do something to the machine, and you come in the morning ready to energize it. Right? So each person should lock out the machine and tag it out. Right? Very essential when doing teamwork and we have more than one teams. All right, we showed this picture last week and we'll show it back this week. Show you how to apply the lockout and tag out of our isolator. Right? Very effective, guys, and you need to follow it. Now, planning the work, right? We talk about this, planning work. plan to avoid falls, plan to lock out and tag out, remove jewelry in terms of rotating machine and electricity. So when you're working within panels or near electricity, remove your jewelry, avoid wet condition on power lines, right? Now, this is what we look at last week, right, where we talk about the flow chart as it relates to the integrated safety management process, right? Now, this process applies to electrical work, right? Whether in partial or in full. You have the project description, you have to define the scope of work. Whether the scope, the work large or small, this process most of the time is followed. It's just that sometimes if the work is small, it is not documented, right? So documentation does not mean that you don't have a process internally or you haven't gone through a process, right? You have to define the scope of work. Person call you and tell you that they have a generator and they want to service, right? And I don't know if I'm going to be able to do that part of the course because last year we serviced the generator and we start the generator, but COVID is here. Right, and being that COVID is here, we have social distance. I try to do as much as I can. You have a lot of persons benefit from it. You have the generator course at UTech where you have to pay for them to teach you how to service the generator, but it is a part of your course, and I tend to do it, right? So when I reach that part of the course, guys, I'm going to send out a schedule. It might be not in your class time, just work with me because of COVID, I can't have too much person gather around the machine. And that's a big generator if person realize it by the JPS Power Lab entrance, the glass entrance, there's a generator there. That's a generator I'm talking about. I'll give you the generator checklist. I'll tell you what to look for and these things, right? But as much as I can work with me when we come to servicing of the generator, we want to carry out that process, right? So we don't want to have to scrap it, right? And again, I say, guys, it might not be in a class time because we just can't facilitate the size to do the exercise within that time, right? It might be a little bit over your class time is a 3-hour slot. So we might have some people come in at different time too, as well as it probably have to be some other day for some persons, right? But we work with each other and see how we can facilitate it, right? Now, analyze hazards. So that's the next process. So the first step is to define the scope of work. The next step is to analyze the hazard, whether you're going to need a ladder, the type of ladder you're going to use, whether you need a different access equipment such as a scaffolding, because you have to go maintain the generators on a roof. You need a ladder to access the roof, the length of the ladder, the type of ladder, right, going to play a part, because if the ladder is not directly involved in the maintenance process, then you probably can use an aluminum ladder to access the roof to service a generator. But for instance, you are servicing a line, right, where you need to be on the ladder, then you probably need a fiberglass ladder, right, which is non-conductive. So again, you have to plan for that. Develop the control that you're going to use in place. As again, that we're talking about the type of ladder. So that is the control, right? Whether it's going to be engineering, administrative, or whether you need to go read up on something before you start work, you get a new piece of equipment. Perform the work, right? Now, when you perform a work, guys, and this comes down to experience, it means that if me do I work today, I must learn something from the work. Whether I do it before or is it the first time I'm doing it, each time you do a process, you should learn. And the next time you should improve on how you work, whether it be safety, whether it be speed, whether it be to add another step, you always need to give a feedback, whether to yourself or to your employer, right? Every time you do a work, guys, because then this is how you build your efficiency and how experience come into place. For instance, I'll say this to you. When I was engaged about 3 years ago to do some work for rural water, right? And for persons who know, they are the contracting agency for NWC, right? As it relates to waterworks. And they were using a new device. They research and they bring in a new device. This device is really a solar drive again, right? It's similar to a frequency drive, but it is classified as a solar drive. Now, how the solar drive works, guys, is that it can be connected to a renewable energy source, whether it be a photovoltaic system, a wind turbine system, and it also have an input for mains, that's JPS, utility company, right? Most of these projects that they were doing, it was in as a name state, rural areas that are isolated and in some bush area. So like when you look, whole heap of bush and no JPS line in sight, right? So they were using solar, and they built all of these solar platform and installer. And I was designing the control circuit for it for the first time, right? That time I had to do about 2 day reading and read the manual, learn how to program the device, the different modes of the device can run in, and all of these things. And then when I read up, so that I will, and the type of protection I need, what I need to install, use to install the device, and all of this, and do my circuit. No, the first time I was doing it, it took me a while, right? Now, I am doing a number of projects, right? A lot of them come on the TV where they must show you people in the community, them and them get water, and them never have water for much years, because what they are doing, these projects are harvesting water from rivers and streams, and we build the tanks them, right? We design the control, the solar system and all of that. My part of it is the control and the solar system, right? And we pump to the communities and so forth. They put in their treatment, the little treatment plant and all of that, and we pump, and they pump to this the thing. Now, when I go, right, first time, it took me a while, as I say, I wire the control on site, guys. Now, I know what I need to prepare and what I need to wire on site. When I go, it's probably an hour I'm spend. I'm done all of the wiring, all of the control and leave. No, that is how you learn from your previous process. I know what I need to carry, I know what I need for safety, I know all of the protection I need to employ to protect the circuit and all of these things, right? So as you go along, guys, you need to learn, and that's how experience come into play, right? You need to learn how to, if you do a job today, you undercharge yourself. You can't undercharge yourself tomorrow. You might lose for today work, but tomorrow may expect you to gain what you're supposed to gain, right? And this is what I mean by feedback. It might not be to somebody else, but it can be to yourself, right? And it can be a process, right? And how you improve your process, right? It might be a tendering process for persons who are in the class and probably do contract work for themselves. When you do your first tender, it's going to take you a while, right? When I do my second tender, so the first time I do a government tender, it take me a while. No, it's just 1, 2. Right, I know what to tender, I know the government no pay tax on them thing, so I have to add in tax, I know this, I know that. So what I'm saying to you guys, you need to learn from the processes. Whether it be safety process, you need to learn what you need to do, right? You need to improve on it. Probably sometimes say, say, if I build a little thing, I'm going to workshop and I build this, I can operate that thing more safely, I can do my work more safely, right? So these are things that you must look at, guys. All right. Planning each work, right? Every electrical job shall be planned in advance of performing the job briefing, right? Planning can be formal or informal, meaning you can write it down step for step, or you can just plan it out mentally. You can discuss it with your business partner, right? You can say it to your workers, this is planning, right? So when you plan, you can get the input from your workers and other persons. You don't have to just leave it up to yourself and burden yourself, right? So you need to plan properly, get others' opinion, right, and so forth. Assess the level of risk involved on thing, because you might be away from the project. You might reach to the point where you have workers right now, right? And when so you are not aware of the processes no more. And if your worker go and say a little step, please be adaptive to listen to him and see how you can, or her, and see how you can improve the processes, right? And we talk about the 3 different steps. Now, training, very critical. You know why? De-energizing equipment is critical. Working on live equipment is critical. You have the necessary training. How to inspect equipment and tool is very critical as an electrical person, right? Every time you use a test, your multimeter, you should inspect the leads. Because you never know which day something happened to your multimeter, and you don't want the thing that happened to your multimeter cause shock or serious harm to you, right? Recognize processes where you need lockout and tag out. You need to be trained how to do that, right? You have different lockout devices, as I can see. The most effective is using a small padlock, but there are other ways. In today's society, certain standards have to be maintained. So most electrical enclosures that you buy, most electrical panels that you buy will have a lockout. It will facilitate lockout, right? Use appropriate protective equipment. Make sure you're wearing your size. If the shoes are squeezer, it is not appropriate, right? It will become a hazard. If the shoe is too big, it will become a hazard, right? If the helmet too big, it will become a hazard. Right? Meaning, so when you ratchet it down, it now will fit your head, right? So make sure that you buy the appropriate protective equipment for the job. So in summary, for this presentation, I remember I said I am on the time clock for 1 hour, right? We talk about the National Fire Protection Agency, their 101 Life Safety Code, and that's something that is very relevant in your area of study, right? As it relates to safety, it covers like emergency lighting, it covers lighting and a whole level of lighting for different facilities, which we're going to look at, and so forth. So it's a very crucial document. I'll try to get a PDF version, right, and see if I can upload it to the website. You have the OSHA electrical code, right, which you can make reference to again. This is similar to our Jamaica standard, right? We have our local standard. We have the IEE regulation, which is very close to our standard as well, right? So all of these you can make reference to. Guys, if you don't follow these and these codes, then you pose a problem to yourself in terms of safety. You pose a problem to your coworker, you become a problem. You put them in hazardous situation, right? And you also put members of the public in hazardous situations, right? So it's very crucial that you make reference to this. We don't expect you, right, to know everything. I don't know everything. When I'm doing a new project, I need to look up certain codes and remind myself, refresh myself, be aware of them before I can do the project, right? The thing about working in Jamaica as an electrical engineer, it involves a whole heap of electrical installation, right? So if that's something, you cannot shy away from it and say, because I'm an electrical engineer, I don't need to know the installation part of it. That's a no-no. It go on and on, right? You have to know it. Because I'm an electrical engineer, I don't want to do certain work. It don't make no sense, because if you are building your company from scratch, guys, 90% of the time you're going to need to be in the field, right? You need to build up your customers' trust in you, right? And that trust involve how safe you work, how you think about the safety of others, right? How you think about the safety of your fellow workers. Because most of the time you and somebody going join together and start a little thing. Or sometimes you can start a little thing by yourself and it grow, right? But you always need to think about safety. You need to consult your Bibles, and not say Bibles that mean in your electrical code books, whether it be the OSHA book, whether it be your JS21, whether it be the IEE regulation, whether it be the NFPA codes, you need to be aware of them. All right? So that's the end of this presentation. That does not mean the end of the lesson, guys. I still have safety application to go over, right? So safety application basically involve how we apply all of this that we have learned so far to our working conditions, right? How we apply it and how best to apply it. So let me bring up the next slide for you guys. In a minute, the computer moving a bit slow. All right. One second. This thing giving me so much trouble. Alright, so you should be seeing a slide coming up now, right? Alright, so we're looking at life and safety application, guys, and how it applies to our You guys see the presentation?
Yes, sir.
Computer, you moving very slow now. I don't know why it turns slow. Alright, so health and safety application and how it affects our safety at work, right? So basically looking at different ways how we can apply all that we have learned so far to make our working environment much more secure. All right, safe working above ground. Working above ground in itself, as I said before, is an hazard, right? And it carries the risk of falling, right? On the picture here, you see the person falling off a step ladder might become electrocuted because it look like him doing some electrical work or something like that. Or again, the ladder might be not resting squarely on the ground. But so there are so many reasons that can prevent that can cause a fall from a ladder, right? And we're going to look at different aspects of working above ground and the risks associated and what are the good practices. All right. So this working above ground is covered by the work at height regulation. This was basically established in 2005. Right. So this regulation is pretty young. Right. And because of all that was happening on construction site, meaning scaffolding towers collapsing and so forth, this regulation was actually adopted and passed, right, to protect persons that are working and also protect members of the public. Right, this regulation speaks to certain aspects. So I pick out a few points here. Avoid working at height if possible. So meaning if you can work on the equipment, pull down the equipment and work on it. For instance, you are installing a fan. If you can, or repairing a fan, if you can remove that fan and repair it and then replace it, it's always best to do so. Right? So avoid the working on a lot of an extended period. No work must be done at height if it is safe and reasonably practicable. And we use the word reasonable practicable to do if other than at height. Meaning, say, again, if you can remove it, right, remove it. Don't work on it at height. Use work equipment to prevent fall. So we're talking about ladders, we're talking about scaffolding towers, we're talking about independent scaffolding. Yes, there are a lot of different types of scaffolding, right? Some of which I'll not even mention in this class, right? In today's society, when everybody trying to put their product on the market, there are so many different types. But I'll go over the basic types with you guys. For instance, use work equipment to prevent fall and also use the safety measures that are put in place for these equipments, right? Here I put an example that, for instance, if you are using a scaffolding, you must use the rails with it, right? And you must use the toe boards with it and also the scaffolding platform tower. That's the boards and so forth, right? Where the risk of a fall cannot be eliminated, robust platforms must be built so as to minimize it. So put that in apostrophe, very important, because you are not going to be able to eliminate it, but you will be able to minimize it, right? So you're not able to eliminate it, but you are able to minimize it. Now, if you are able to minimize it, then it will minimize the risk of you falling. This may be by means of building a step pyramid type of a platform at the work site when the risk is high. So rather than using a ladder, they're saying it's better you build a step system to access the platform, right? Meaning, if you have a whole heap of person use a ladder, right, then the ladder run the risk of becoming loose, whether you secure it or not. So it's better to build a temporary platform. And this is noticeable when you're looking at construction work in like America and Canada for persons who have been there and seen the construction work taking place, or a see it on some program, right, building programs and do-it-yourself programs. A lot of time, what they'll tend to do is put in a temporary elevate and tall high-rise building rather than using the steps and so forth, right? Because it runs the risk of becoming fatigued, and when you're carrying equipment, certain equipment that are portably need to lift it in place, and the crane might not be the most suited means of lifting such a device. It's too small for the crane, but too big to carry up a step system, right? So these are where this is how you evaluate working at these heights and so forth. Couple years ago when they were, I think about 2 or 3 years ago when they were repainting the engineering building, that's where they use the independent scaffolding. Now, the independent scaffolding is basically a system of tubes. You just get some tubes and use some clamp and you build the system. One thing I wanted to point out for persons who weren't here at UTech at the time and see what was happening is that while working on height, whether the persons are on a secure platform or not, they were all wearing harnesses that were clipped to the platform itself, right? Because anything can happen. It's known as an accident because it can happen at any time, and you don't plan for accidents; they just happen, right? You can slip, right? You slip, even if the rail is there, depending on how you slip, you might go over the rail, right? And all of these things. Now, if you are not clipping the place with a harness, then you run the risk of falling off the platform and probably start eat fish and bread and people come look for you in a casket and them things that we don't want that, right? Even electrical workers, because you might say, why, sir, I do electrical engineering, but now go there on a height and thing. No. A lot of time I can tell you this. When I was doing my studies, right, I got a summer job at Petrojam, and I'm telling you, summer job in this case, and I never know that being a part of the electrical department, I had to go. That's my first time experience height like that, right? I had to go on the storage towers to change some control, work on a control circuit and change the defective items. Now, for persons who are unaware, the control circuits are right at the edge of the storage tower, right? So even though the storage tower is there and you're on the top of the storage tower, right, there's also a mechanism there that you clip your harness into, right? So I have to put on the harness system or to clip it in place. So while working, because it's so near to the coastline as well, we have high wind, right? You have fumes on the compound, so you smell fumes, right? Or it can make you become nauseated and not aware of your environment. You have wind, gusts will up one blow you off of the building, and then to couple that you are working on an electrical circuit, right? So then again, you can't leave out working at heights, right? Even if you get to supervise some guys, most of the time you are going to be able, you have to go on site and you have to go on the platform and you have to observe what they have done. All right, so it's very critical, guys. Now, when we're talking about ladders, we talk about to keep the ladder safe and to apply good safety measures, we have to inspect the ladder. Now, if you are not competent, you are not able to inspect the ladder. And I am saying competent means, in this case, that somebody that is trained to inspect a ladder, right? Because you need to know what to look for. Now, you go doing this course, you are now going through a training process, right? So by remembering these things, you have done some amount of training and you should be competent in a way to inspect a ladder, right? So we say ladders are generally used for access or work for short duration, right? So whether involve step ladders or trestle, these are all used for short work duration or for access, right? Anybody ever work on a ladder for extended period will tell you that after a time, the rung of the ladder, that's the part that you hold on and climb on and you put rest your foot on, will start to squeeze into the sole of your feet and it becomes uncomfortable. And that uncomfortable feeling is what will cause it to fall, right? So we use ladders for short working period and for access to other levels, right? Now, how do we inspect the ladder? Because before we become competent, we have to know what to look for. It is advisable to always inspect your ladder before you climb it. The ladder should be straight and firm. So we don't want a wooden ladder with no bend on it because it means that at the point where you have the distortion, that's where the stress is going and the force is going to be concentrated, right? If the ladder is not straight, you will not have the force concentrated on where the ladder rests on the ground. right? If it bend, you're going to have a shear force exist, and that shear force can cause the ladder to snap, right? No, the ladder should be free of damage such as cracks. In the case of metal ladders, they should not have any corroded parts. They need to inspect for corrosion, right? Corrosion meaning it will hide the defect, right? In terms of timber parts, you need to look for, if you're talking about board ladder, you have to look for deterioration of the board, right? Such as insect, if insect and termite gone into the board, if it's split, if it have crack. In terms of fiberglass, we are talking about deterioration. For persons who don't know, when a fiberglass deteriorate, it will start to itch. Right? So if you have a fiberglass ladder that has deteriorated over a period of time, exposed to the elements and with time, it will start to itch. Right? So when you climb the ladder, finish using the ladder and put up the ladder, in the evening you wonder, oh man, itch so. Oh, when I go in the bathroom and I bathe and I rub my skin, things that prickle and a juke and this is because the ladder is deteriorated, right? Now, once you find any of these defects, right, you need to take the ladder out of service and replace the ladder, right? And most of the time, a lot of these defects cannot be repaired. Fiberglass ladder will split also. So you see your cable and wireless bridging, them name cable and wireless now, them name flow now. So you see your flow bridging come and say, boy, I'm have a ladder, sell you. So I'm come with the ladder and say, I'm sell you the ladder. The ladder was, if you, for anybody who know, if you are talking about a 20-foot extension ladder, fiberglass, we're talking about roughly $50,000, right? Now, that's one of the good 20 feet and extension ladder, meaning it can extend to probably 30 something more, because you have to have some of the rungs them overlap, right? So we're talking about that, we're looking at roughly $30,000. And then say, why am I selling one ladder? $20,000. But you know why am I selling the ladder? Because he buy it from him company for little or nothing, because then take it out of service, probably pay $5,000 for it, right? Or probably pay $10,000 for it. But they are selling it because it has done it life work, right? It's in the process of starting to deteriorate, so the fiberglass might start to itch. It might have some cracks on it, it might have some split on it, right? And you start to use it and you realize it itchy and all of these things, right? So you need, and then after a while, so you don't get no time for use because you never buy a new ladder. And you probably get a 1 year left out of it or a 2 year, and then after that you have to buy another ladder, right? Meanwhile, probably if you save and buy a new ladder, sometimes you don't have the money and you have to do that, but you might have other ladder what will last a couple of years if you take care of it, right? All rungs and ties must be in place, meaning all the rungs them and the tie for the rungs them, you need to check them. Or you check them, you have to actually shape them. You can't look on them and say, oh, the rung they look all right, man. If you actually check them before you start to descend, or if you are ascending the ladder, you need to shape them before you start to ascend and put your foot on it. So every rung, as you go up, you shake it. You give that little shake with your hand, while your hand is on the side of the ladder to make sure it's secure. Right? These are things that you can do. Rungs must not be painted, right? Because the paint them have a eye crack and split. If you get the fiberglass ladder, that's why the fiberglass come colored, you know. Because they don't want to say, boy, the fiberglass look old now, and you buy some spray paint and you carry it by a compressor from your brethren, and you carry it to your brethren and him spray it. Because once you spray it, it will cover all of them defects, then the crack then cover the split, and you can't see them, and you put yourself at risk, right? The rungs must be clean and free of grease, right? Grease causes slippage, so you need to clean your ladder regularly. Yes, you need to clean your ladder, you know, just put it up and just left it, right? Every now and then you wipe down the rungs them and make sure so them clean and free of grease. Well, the grease will cause it to slip. Aluminum ladders must not be used near low or high voltage cables. Remember we talked about that a while ago, right? You're working near electricity, aluminum ladder is a no-no. We talk about fiberglass, and this is why the floor guys then get fiberglass ladder, the digital worker get fiberglass ladder, and the JPS workers get fiberglass ladder because they are working around electricity, and these fiberglass are non-conductive. All right. How do we use ladders? Safe use of ladders. Extension ladders must be erected in the closed position as shown, meaning it should not be extended, right? Each section of an extension ladder must overlap by at least 2 rungs, right? So you can't extend the ladder fully. And that is why I'm telling you, if you have a 20-foot ladder, you will not get 40 feet of ladder if you extend it, because you must have at least 2 rungs overlapping. And this is basically done to put the force on the base of the ladder and not where it overlap, right? If you don't do that, then the force, there's going to be a shear force where it overlap, and if you extend, exceed the weight limit of the ladder, yes, ladders do have weight limit. If you buy a new ladder, you're going to see it paste on the side of the ladder, right, to tell you that this is the maximum weight that the ladder can hold, right? And if you exceed that, then you run the risk of the ladder collapsing due to shear force, right? So I'll show you a diagram here that shows you the process in terms of erecting the ladder, right? Safe use, right? The ladder must be mounted in the 4 up to 1 out or at an angle of 75 degrees. What do I mean by 4 up, 1 out, right? Each rung of the ladder, between the rungs of the ladder is approximately 12 inches, right? Which is basically 1 foot. So I'm saying for every 4 rungs, we need to go out 1 rung, the distance of 1 rung, right? So for every 4 rung, so we'll call it the 4-to-1 ratio. For every 4 rung, we'll go out 1, right? That's basically when you, so if you count the rungs of the ladder, right, and you have 12, right, so this should be actually 3 feet from the base of the building, the vertical to where the ladder foot rests, right? So that's basically what we're saying. All right, going further, right, we talk about the top of the ladder must be secured if we're going to use it for access equipment. So you can tie it, you can nail it, you can do all you want to do as long as it is secured, right? So you need to secure the ladder properly, right, at the top where it's resting. Now, where the ladder rests on the top of the building, you should not be reaching to go to the building. So, for instance, when I go back to this slide, so the building top is here and the ladder end here. This is a no-no, because you should not be stretching to climb over the building, right? The ladder, this building should have rested here, where you can ascend the ladder and step onto the platform, right? So we don't stretch for platform. Only part time we do that, and if you don't have persons to assist you when you're coming back down to tell us, yeah man, your foot near the ladder, you're near all of that, right? That is the reason why you don't do that. You can slip and fall, right? So we try to have the ladder to extend at least 5 rungs above the landing platform, right? So 5 rungs above the landing platform at least, right? Or 1.05 meters, right, above the platform. So they said that a ladder should be erected close to the work site and do not overreach. A lot of times you see persons stretching on ladders. This is basically a no-no, right? It's not something to practice. When you stretch, then you change the direction of the force and you run the risk of falling over, right? The ladder must stand on firm level ground and be secured at the top, right? Step ladders basically the same, right? However, with step ladders, all the foot must be squarely on the ground, firmly on the ground and so forth. The securing device of the step ladder must be fully extended and locked into place, right? And so forth. Do not stand on the top platform of the ladder. It's putting tools and so forth, and also a tool platform, right? Do not stand on these, right? Very critical to cause the ladder to twist and fall, right? Only one person at a time should be on a step ladder. It's designed for that purpose, right? Now we talk about scaffolding. These are for working extended period above ground, right? This is a trestle scaffolding. This is one of the simplest scaffolding to erect. And you can use 2 ladders to do this. You can actually use 2 step ladders to build a trestle scaffolding, or you can use 2 platforms and have a scaffolding board going across. The masons love to use this type of platform because it's easy to erect, right, and easy to pull down, and it's very useful in working for extended periods above ground, right? We'll tell you some more about the trestle scaffolding. You can read up on it. This is some little detail. Most of the time you won't remember these details, but you have to get them and you have to go through them, right? Especially this one, at least 1/3 of the trestle must be above the working platform, right? The scaffolding boards must be of equal length and not overhang the trestle by more than 4 times their thickness, right? Meaning that you must not stretch it out too much, because then you run the risk of this part of the board becoming too flexible, right? So it's very critical. All right, mobile scaffolding towers. So basically all the scaffolding will have similar effects, but what they are used for is going to be different and how they are worked. Now, mobile scaffoldings are really scaffoldings that are made in and you have to transport them by means of hauling them on a device, right? Such as a truck. So this is an example of your mobile scaffolding, right? So it's unable to pull down. So it's built this way, right? You have your guardrail, you have your toe board, right? You have your diagonal bracing and so forth, right? And all of that. And now, the purpose of the toe board, you might wondering what's the purpose, right? The purpose of the toe board is really for when you are working to tell you when you are at the edge of the platform. Because remember, you know, when you are work, a lot of time you are aware of when you're at the edge. So this board is in place to tell you that, listen, you're at the edge of the platform, any further, you will fall, right? So once your foot rests on it, or bounce against it, you realize that you're at the platform end. All right, and we have the wheels. While using them, we'll lock the wheels into place and so forth. This one you won't see much being used in the work activities, right? But this one now, so these are basically similar to what you had seen before, right? For extended period above ground and work and so forth, right? Now, what you need to understand about these types of scaffolding is that the tower scaffolding is much different from the mobile scaffolding. Now, with this tower scaffolding, right? These are basically some of the type that you'll find on modern work site, right? They have a lot of locking mechanisms. So like for instance, when you stop them into place and put the diagonal brace, you actually latch them in place, right? So rather than using your clamps and bolts like your independent scaffolding, these are the one where you buy to use at your home for small projects. They probably come in different sizes, right? And you buy them up here, or you buy 2 pair and you fix them together and you snap them into place and so forth. It's very easy, right, to erect compared to that of the independent scaffolding, right? This is now your independent scaffolding. And this is what I'm telling you about the different parts. All it comes with is some tubes, right? And you use your bolts and your clamps and so forth and clamp the vertical into the horizontal, and you use the safety mechanism to lock it to the building and so forth through open windows and so forth, right? So the independent scaffolding is being used a lot on our construction site. Normally it takes the scaffolding to the team at least two to a week, up to a week to erect the scaffolding depending on the size of the site, right? Normally the persons who erect the scaffolding are trained to do so, so they'll probably train a number of their staff. And these persons, you might have a tradesman on the side that not even know how to erect the scaffolding. All you know is that the scaffolding team mount the scaffolding and then go and work, right? And so forth. And again, you can't say you're not going to be on a scaffolding, because if you are talking about an apartment complex and you on a team that get the contract to install the electrical, we're going to talk about outdoor lighting and so forth, and you have to be on the platform to install these type of lights, right? And to inspect them. All right, so these are just some guidance on the measurements for the toe board. Should be at least 6 inches high, right? The handrail must be 3 feet high, right, above the platform where you stand on. The distance between the boards must not exceed 1 inch. So that's a gap between the platform board. Anything more than 1 inch, you run the risk of objects falling through it and other persons. Also, you bucking into one and falling and slipping through it and so forth, your foot slip and all of that, right? So it's very critical, and that's why I say, again, the guys that put up the scaffolding is trained to do so. All right, working below ground. So we talk about working above ground, but what about working below ground? We talk about basement level work, right? We talk about confined spaces. We might be in a tank or work. We might be in a well, install a pump or something like that. So you cannot say again that you're not going to encounter this situation, because them put the submersible pump in the well. You as the engineer, the electrical person and the team have to go into the tank to connect the pump, right? You probably have to go configure the pump for different voltage level, whether it be delta or it be star, and that is why I learned this guys in class, right? So the pump probably come with 2 different level voltage, and you probably have to connect it in delta or star depending on the application that you're doing, right? So working below ground, we run the risk of ventilation going to be one of your most critical part, because when we're talking about below ground, we're talking about no windows in place, right? So ventilation in this case become an aspect, and we run the risk of suffocation, right? Or asphyxiation from lack of air. So for persons who are claustrophobic, you realize what we're talking about engineering now? Engineering is like you have to overcome everything. You have to overcome your fear of height. You have to overcome your fear of small spaces. You have to overcome your fear of electricity. So if you fear electricity, you have to overcome this. So, and that is why when we talk about engineers, guys, we talk about persons that are all-rounded. Most of the time when you talk to enough engineers and then tell us when they have something to do at home, them do it themselves, unless them not have no time on them get somebody, right? Because like you're trained to research, you are trained to read, you are trained to do practical work, right? And you want to explore these different areas. All right, when working in trenches, right, we'll probably have lay some cables, some SWA cable in a trench, and we need to make connections in your manual and so forth. You probably have to work in trench, right? You'll probably be a part of the team, say electrical SWA cable burst, and you are part of the team to splice it back. You have to be in the trench for hours, you know. It actually takes hours to splice back a SWA cable, right? It's a very tedious task. Now, some good practices when working below ground. Where are that? Never go into an unsupported excavation, meaning it must be secure. You can't have dirt around when you're in the excavation. You must erect your barriers so people not drive car in there and you know, right? Provide good ladder access. Ensure the work is properly planned. Take account of the risk assessment before starting the work, right? So these are some practices that we can employ when working in trench, guys. Now, working in confined spaces now, this is where the oxygen become a very critical part. So let me give you an example of what you might be doing. You might be working in storage tanks and silos, right? You might be working in a pumping station, right? You might be in a furnace, you might be in a ductwork, or try find a connection, right? And all of this will be basically working in those confined spaces. And then the most important thing in these spaces is actually getting enough oxygen, right? So if you find somebody that is in one of these spaces and they become unconscious, the first thing you need to do is not panic, but try to get the person in a location where they can have enough oxygen to revive them, right? So that's basically confined spaces. Now, when we're talking about approach distances, guys, I'll give you a picture of some of the relevant approach distances when working with electrical panels, right? Now, when working with electrical panels and enclosures, we're talking about the depth distance, right? This is approximately, it varies as the thing says, and we're talking about basically 6.5 feet minimum, right? So that's basically your mounting, right? And the clearance of your electrical panels and enclosures, right? When we're talking about your front view now, your space, working space, we're talking about 30 inches, which is basically 2.5 feet, right? And we're talking about clearance to work, right? So while working, you should not be obstructed by other objects in the way. You have to have clearance. And this is why the regulations are so important, because it is saying that if you are installing a panel and you can't meet these clearances, the panel should not be where it is, right? Because it means that when the person comes to work on it, you are going to put them in danger. So for persons who have done some electrical work before, you would have encountered some of these situations where you have to have the panel in particular location that is readily accessible, right, to persons in the household or the facility. Now, in facilities, it's kind of much more tricky because a lot of time they have the panel room, right? And sometimes the panel rooms, to prevent unauthorized persons from accessing the panel rooms, the maintenance personnel will normally have the keys for these rooms. All right, and so they have a lockout process where they lock out unauthorized staff. All right, so we'll put some distance in condition 1, condition 2, and condition 3. What does this mean now? All right, condition 1 means that you have electrical equipment on one wall, right? So you have no live or ground parts on the other wall, all right? And condition 2 is when you have the electrical panel, but you have probably some parts on the other wall that are metal in nature and need to be grounded, right? So that's condition 2. And then condition 3 now is where you have live electrical parts on both sides, sides, right? Some panel rooms in large facilities will look like condition 3, right? And there are certain clearances that we must observe. All right, so for condition 1, we are telling you that for a working voltage of 0 to 150, that's this condition, there must be a clearance of 3 feet, right? Also condition 2 and condition 3. If we're talking about a voltage of 151 to 600, condition 1 will remain 3 feet, but condition 2 will become 3.5 feet and condition 3 become 4. And if we're talking about voltages now in the range of 600 to 2,500, condition 1 remain 3 feet, while condition 2 and 3 changes to 4 and 5 feet respectively. Right? And high voltages now we're talking about 5 feet for condition 1, 6 feet for condition 2, and 9 feet for condition 3. Right? That is why when you go to the substation where you have equipment on both wall, right, you have a clearance of 6 or 9 feet. Well, inside the substation where you have the medium level voltage, where you have 9 feet. All right, when you have things on both walls. All right, live testing, we said that the person must be trained. Again, we iterate that because if we're talking about clearances, most of the time you are unable to turn off one panel or a next and you have to work live. Now, one thing I need to point out to you that, and I've done this, but it's not a good practice. For instance, you are connecting a new circuit to a panel, right? Most of the time, you might be doing this activity when persons are using the electricity. So you're unable to de-energize. Now, if you are running a new conduit system to a panel, you're going to need to use a fish tape. And if you are unable to buy a fiberglass fish tape, right? Remember, we say fiberglass is non-conductive. It means that you're going to have a metal fish tape. And if you have a metal fish tape, guys, and you are pulling the wire into the circuit, you need to be careful now. The best thing to do and what regulation states, right? So your OSHA requirement, your JPS requirement, your JS21 requirement require you to de-energize the panel, right? And carry out your work. But a lot of time you cannot do this, and this is why you have the tool for the job. Now the tool for the job is your fiberglass fish tape. Right? But again, you can't have a fiberglass fish tape because probably a cost, it's very expensive, right? And you just don't have one on hand. One thing that you can do is isolate the bus bar, right? So you can get a plastic shielding, right? And tape it over the bus bar, right? So you can pull through that wire much more easily. But again, a lot of time that going to take time, and persons are look on time, they're going to look on to get plastic and to do this and all of that. And you know, it take up time. So the next thing you do, you just work on the circuit live, take your time, do what you do, and most of the time it can cause a breaker to trip. Not only that, it can cause the panel to catch fire from short circuit. Not only that, it can electrocute you, right? So when we're doing this type of job, guys, you have to be as careful as possible, right? Our final topic before we move on, we're talking about manual lifting, right? So before we finish up lessons today, so we don't have any tutorial today. I don't send out the tutorial sheet yet. So we're talking about manual handling. So what is manual handling? Manual handling is basically the lifting and transportation of loads, right? Whether it be by using a truck, a system in place, whether you're using bodily force, right, or by hand, right? But when we talk about manual, we talk about mainly the hand, right? Now, when we're carrying objects with the hand, right, it runs the risk now of the object even falling, resulting in sprains while lifting, right? Result in trips, because while carrying manual stuff, you can trip as well. So how do we guard against this, right? we guard against this by carrying out proper safety procedures and applying them. Now, there have been, so put on talk about a point. No, there is also a regulation that was developed in 1992 that also speaks to manual handling, right, of equipment, right, such as tools, such as toolboxes, such as small equipment when you're transporting them by hand, right? No, this regulation states that there is a correct and an incorrect way of lifting objects. Now, the demonstration here shows that you are, when lifting an object, you need to adopt certain principles to avoid back injury. One is to bend your knees. So rather than bend over your back, you bend your knees, right? Try to keep your back as straight as possible and lift with your hips. So you realize that the person is lifting with their hips. They don't have their legs straight now, and then trying to lift the object. This will cause a strain in your lower back, right? So we bend, we keep our back straight as possible, bend our knees and lift with our hips, right? And carry the object. Now, when carrying object, we try not to stack objects, right? Stacking means blocking your line of sight by stacking objects taller than your sight, right? So once it's blocking your line of sight, you run the risk of bumping into other objects or tripping on other objects, right? So we say, in doing this now, to avoid all of this strain and this pressure on our body, if it's possible, try to use a system, right? Whether it be a hand trolley, whether it be a hand truck, right, and so forth. Try all your best not to lift. Now, if you definitely have to lift, then your employer must train you how to lift. Meaning, if him see a lift the wrong way, is something that him should point out to you. But because we are in Jamaica now, persons now must say, boy, them lift you to your own device and make you a lift on that. No. If the work involve a lot of lifting, they must give the appropriate equipment and they must teach you how to lift it. Meaning, they must give you a back brace, they must give you a hand chuck, right? Because sometimes then the load becomes too heavy and all of that. So they need to promote, right, safe manual handling on the job. Now, some of the good practices. Do not lift the load manually if it is more appropriate to use a mechanical aid. Only lift or carry what you can easily manage. Always use a trolley, wheelbarrow, or truck when these are available. Plan ahead to avoid unnecessary or repeated movement. Meaning, if you can carry it in a one move, do so. So you don't have to repeat the process over more, because as you carry the stuff, your body becomes more fatigued, right? And we are at the end of our lesson. So that's it for today's lesson, guys. Let me say again that there will be no tutorial today, right? So persons who are looking for a tutorial, there is no tutorial today. However, right, however, next week, I will be sending out the tutorial this week, because I'll cover enough to give you some questions now. So these questions will gear you to additional reading. That's why I will give you a tutorial. They'll also test you if you are reading, right? And they might all turn up back on your test, who to tell, right? So these guys, when I give you the tutorial, try to go through them, try to ascertain as much information as you can in the tutorial session. Meaning, do the question before you come to the tutorial question, so you can ask me questions, right? If you not do the question, I'm not going to come and just tell us, all right, we will go through the tutorial and give you the answers. I need you to attend the tutorial question, because for safety, a lot of the tutorial question is you explaining and discussing and describing stuff, right? There is no much calculation for safety. Well, there is no calculation for safety. All right, so you just need to go through the tutorial and do the work. Now, please remember, I don't remember who is doing the recording, to send it to me, or you can just send it to your WhatsApp group, because you have a WhatsApp group. I don't know why the recording not coming up on my device today, right? It was there for my class earlier, I'm not seeing it now, right? But you can check later. I will put up the presentation for this, for later, for these two topics, later on the website, right, for you to be able to access, and I'll try to upload the tutorial as well. All right, so you should have some material. Now, as for the test, I've not, remember it's after unit 2, so we are going to be looking at unit 2, right? Yes. So when we finish electrical systems, we will give you a date for the test while doing that unit, right? So after finishing the electrical unit, that's it, electrical systems for facilities, we will be conducting our first test. And then our second test will be after completing unit 3 and 4 from your outline. Any questions so far? Yes, no?
When I click on the recording in Moodle, it is asking for a request to be sent.
Yes.
I did so.
Yes, Mr. Fred, I was told that for by other persons. So what I'm going to do, rather than individually going through and clicking access, I'm going to see if there is a way for me to grant access to everybody who have the link. If not, what I'll do is upload the recording to the Moodle platform. All right. So what I did was actually link the Moodle, the link that you see in Moodle to Google Classroom, but the two systems not corresponding. I want it to. So I'm going to do a little bit more research by later and see if there's a way for me to give multiple access without me have to go into my email and give individual access. All right. So
All right.
I'll try to do that before the end of the week so that they can have the videos. All right. Any other question or concerns?
Sir, do you know when you're going to upload this presentation?
I can upload it right after I finish with you guys. Right?
Okay,
so,
thank you.
I don't have any more class for the rest of the day, so I have some time to upload these material. All right. But also, it's the material that I went through. The slides, they are in the document that I posted on safety. Some of it is there, right? I'll direct you to some books. The thing about safety, there is no one book that will cover all of this material, right? So even the required text will not cover safety to the extent that the slides have done. I would have to point it to so many books because it was taken from so many sources, right, to cover the whole unit of safety. All right. So that's why I try to make the slides as detailed as possible.
Sir?
Yes.
As it relates to the, I'm seeing on my timetable that you have a tutorial session on Thursday, sir. Is still the case?
Yeah, man. That's for the group. I think some persons have their tutorial now at 2 o'clock, and some persons have it Thursday.
Okay,
I also have a lecture session tomorrow evening. And that is why you see 2 videos. So I put both classes. So 1A is for your group and B is for the Wednesday group. You understand?
Okay,
You can watch both of them if you want to know, because sometimes we have a total different discussion, but it's the same slide and it's the same material that I'm presenting. But sometimes persons ask question and it go into a different discussion. You understand? So that's how I
All right, sir. No problem.
All right. All right, so you can look for the presentation shortly. All right, so I'll take my leave of you now. It's now 1:58. So you have your 1 hour to do some reading before any other class, because you would not have a scheduled class for persons who have tutorial after this. Right, I know that some of on Thursday. All right, so have a nice day, guys. And I look forward to you putting out some work for your test 1. All right. All right, so take care.
All right, thank you, sir.
No, I'm leaving. Yes.
All right, sir.